Let's do some examples of surface area using a formula instead of dissecting it using a net. You can do it either way. I just wanted to show you the formula method. So compute the surface area of the figure. The answer is on the next slide. So the first thing I want to do is identify the type of shape this is. Well, since this has two parallel identical faces, this must be a prism, and the bases are triangles, so it must be a triangular prism. Now, just because you don't have the net doesn't mean you can't dissect the shape till you can visualize the net. So we can see this shape is made up of two triangles and then three rectangles, but we might have to really think about what the dimensions of each one of these faces are. Let's start with the triangles. So the triangular face has a base of 8 and a height of 3. So if I use the formula for the area of a triangle, 1/2 base times height, or base times height divided by 2, I would multiply the 8 times 3 and get 24, and then divide by 2 and get 12. So the area of the triangle is 12 square centimeters. Now, notice I have two triangles. So I could do 12 square centimeters plus 12 square centimeters, and I would be back to that 24 square centimeters for the area of our bases. Here's where some thinking has to come into play. For the rectangular faces, the very bottom is 8 by 12, so 8 centimeters times 12 centimeters, which is fine. That would be 96 centimeters squared. But a lot of people struggle with the dimensions of these two faces. Notice that these lengths of our triangle are the same, but we don't know what they actually are. This is where you have to really think about some things. So if this is an isosceles triangle and I split it right down the middle with a right angle, then I have two right triangles with a height of 3, and if I've dissected this perfectly, each one of these is 4 centimeters. So I have a 3 centimeter by 4 centimeters. So now we need to find the length of this third side. You can use the Pythagorean theorem and say 3 squared plus 4 squared equals c squared. So 9 plus 16 would equal 25. So if 25 is the square of the hypotenuse, then the square root of 25 is 5 centimeters. So this side must be 5 centimeters. So I have 5 centimeters by 12 centimeters, which would be 60 square centimeters, and I have 2 of those. So that's a way you can do this shape. Then you would add up your 24 for your two triangles, your 96 for the bottom, and your two 60s for these two rectangles. You may have done it a different way. Let's take a look at the answer. Here's a different formula that you might see on a formula sheet. It has 2 times capital B plus PH, and there's a little key there that says capital B is the area of the base, P is the perimeter of the base, and H is the height of the prism. So if you're going to use this formula and you're not going to think of nets, you really have to realize that this is the base of the shape. So the base of the triangle is A equals 1/2 base times height. So again, we found it just like we talked through it, thinking about the net, so 12 square centimeters. Now we want the perimeter of the base, so we need the distance around the outside of the base. In order to do that, we need to find the hypotenuse of the right triangle. We use the Pythagorean theorem, and it's a 3, 4, 5 triangle. So the perimeter of the base is 8 centimeters plus 5 centimeters plus 5 centimeters, which is 18 centimeters. The height of the prism is 12 centimeters. So if we plug into this formula right here, we're going to do 2 times 12 square centimeters and get 24 square centimeters. Notice that would be our triangles. And then plus 18 times 12. Well, what it's doing is it's taking each one of these lengths and multiplying it by 12 and getting 216 square centimeters. So the surface area of this triangular prism is 240 square centimeters. You could do this dissecting it using the net or using this formula. Great.